now let's discuss about hybridization of carbon in a compound, and about its sigma and pi bonds in an organic compound. So let us let us look into the matter. So if a carbon has 4 single bonds, then it tends to have a hybridization of sp3 hybridization along with 4 sigma bonds, and this is the representation of sigma and this is the representation of pi. And if it was having 2 singular bonds and a double bond, then it was going to have sp2 hybridization along with 3 sigma plus 1 pi bond, where this becomes sigma bond, this becomes sigma bond, this becomes sigma bond, and this becomes a pi bond. And if you look into the third compound, where it has 1 singular bond and 1 triple bond, then it will be having sp hybridization along with 2 sigma plus 2 pi. This becomes a sigma, this becomes a sigma bond, where these two becomes pi bonds. And if you take another carbon of 2 of either sides having a double bond, then it is going to be even the same hybridization of sp along with 2 sigma and along with 2 pi, where this becomes sigma, this becomes sigma, and this becomes pi, and this becomes pi. Hybridations and the number of sigma and pi bonds must be remembered. So now let us take few illustrations and note how many number of sigma bonds and how many number of pi bonds are we going to have. First, let's take this compound. This is so called as ethane, and it has molecular formula of C2H6. And if you want to write its complete structure formula, then it's going to be like this, and it will become easier for you to count the number of sigma bonds and pi bonds. It is having pi bonds 0, as there is no double bond or triple bond, and as for sigma bonds 1 2 3 4 5 6 7, it's 7. And if you take precedingly another compound, it will be, let's take this compound. This is so called as 1,3 butadiene, and if you look at number of sigma bonds, it has 1 2 3 4, the one with hydrogen and carbon, 1 2 3 4 5 6 7 8 and 9. Yes, sigma is equals to 9, whereas pi 1 and second one is over here, pi is equals to 2. And let's take another compound. This is called as ethyne, and let's count sigma bonds 1 2 3, and that's it, 3 sigma bonds, and pi is equals to 2. As you can see, this one and this one is pi bonds. Let's take fourth example as this compound, which is very important in chemistry. It's a benzene ring, an aromatic ring, which we'll be learning about this ring in further studies or upcoming classes. And if you look at the hybridization, each and every carbon has sp2 hybridization. Why do we consider it as having sp2 hybridized? Because, as I've told you, if it has two single bonds and a double bond, then it is tending to have sp2 hybridization. If you take a look at here, it will be having one hydrogen and one with another carbon. See, this will be like this dotted structure. This will become carbon, this will become carbon, this will become carbon, this will become carbon, and this will be the lower carbon. So this will be a double bond, this will be a single bond, and this will be a bond with a hydrogen. Similarly, over here it will be having the similar case. Each and every one will be bonded like this. So hence, as every carbon in a benzene ring will be having sp2 hybridization, if you want to count the number of sigma bonds and pi bonds, then it will be having 12 sigma bonds, and for pi bonds it will be having 3 pi bonds. And if you take, this is called as benzene, right? You have to remember it, it's benzene. And if you take an example with having two benzene rings, this is called as naphthalene. And if you its molecular formula will be generally equals to C10H8, and the number of sigma bonds will be like 19, and as for pi bonds, 1 2 3 4 5 pi bonds. And if you take 3 benzene rings, or 3 aromatic rings, it is so called as anthracene, and its molecular formula will be C14H10, and it has a pi bonds of number 7 and sigma bonds of like this will be given to you as homework. Each will be having a sigma bonds of 26. And that's it